Good morning. Oh wait, wrong country. Welcome to another beautiful sunny day in the life of an electrician in Britain, and today we are installing an Ohme electric vehicle charger. First time I've installed one of these, so it should be an interesting little job. As always, if you like my videos, hit a thumbs up, subscribe, all that jazz. Let's get into it. So this is the Ohme intelligent wall charger, and it's special because it basically syncs up with your energy tariff to get you the cheapest possible charging rate at any given time. So overnight, when the electricity might be cheaper, this little box will communicate. It will read the electricity's cheap now, let's charge up the vehicle, and it can result in massive savings on charging up your vehicle. It has the flexibility to be able to charge up on the cheapest tariff, but also if you need to charge quickly, you can just put it on a normal setting and get it to charge the vehicle up at the quickest possible rate as well. So it's flexible. Now, I've never installed one of these before. There are a few issues with it. Obviously, you know, I usually install the Zappy because it has everything built in: pen fault detection, type A RCD with 6 mA DC protection and all that. This one does have type A RCD built in with the 6 mA DC protection, so that's good, but it doesn't have any pen fault detection. So what that means is we either have to install an earth electrode or a pen fault detection device separate. And today that's what we're going to do, is we're going to put a separate little consumer unit in next to the existing consumer unit with a pen fault detection device provided by a company called Viridian EV. So I will show you that. Before I do though, so this is a tethered unit. Basically this box just fits onto the wall like that. It comes with this 1 meter tail that you just connect into a junction box, and then obviously bring your feed cable from the consumer unit into that junction box, and it just joins onto here. And then it's got this hook that you fix to the wall, and you basically just hang the cable onto it like that. So fairly straightforward, should be a fairly easy install, and obviously there's no serviceable parts in this, so it's literally you just connect it up and go. It's got a 4G antenna in it, and that does the communication with Ohme's servers, and it knows your tariff because you set up an account on this. You tell it what tariff you're using, and then based on the figures that Ohme has for all the tariffs, it regulates your charging accordingly. And it also, you put in your vehicle details, so it knows the size of your vehicle's battery, how long it will take to charge, all that kind of stuff, what the fastest charging rate your vehicle can do. So it's not called intelligent EV charger for nothing. It does have a lot of clever stuff going on in here, and this is kind of the only one on the market really that I know that does that smart capability based on your tariff. So I'm interested to see how this install goes today. So let's get into it. So as I mentioned, we need an external pen fault detection device because it's not built into the charger. So we've got this one today. It's from Viridian EV, and inside here is all the gubbins. So we've got a double pole isolator and then this contactor, and there's a circuit board inside here which does all the smart clever stuff to detect if there's a pen fault and then cut off all 3 poles, phase, neutral and CPC, in the event of a pen fault. That's required because this is on a TNCS system, and even if it was a TNS system it would still be required according to the regs. So it's either this or an earth electrode in a case of EV installs mostly at the moment. And yeah, inside here is some very clever stuff, so I'll get the cover off and I'll show you. So inside here we've got double pole isolator. That's just to be able to cut off both poles, and we'll just feed into this with the feed from the circuit breaker in the main consumer unit. Then we've got this contactor, which is a 40 amp contactor, which is a 4-pole contactor. We're only going to use 3 of the poles, and I'll show you that above. So this circuit board is really the magic, which does all the measuring for the pen fault detection, and it measures both voltage and current in order to detect a pen fault, unlike some other devices which only measure voltage. This has got kind of a belt and braces system, which is really good. I prefer it. I feel more confident in this because obviously voltages can fluctuate, especially in installations where you've got a solar system involved. So what happens here is basically the feed comes in the bottom through this main switch, and then you've got these copper tails that come out the top onto the circuit board, through the circuit board, back down into the top of this contactor, and you've got your CPC, your line, your neutral, and then the fourth pole is obviously not going to be used. That goes through the contactor and out to the EV charger. So effectively what is brilliant about this is we won't everything's in a nice neat consumer unit. We don't need to put, like for example the Mati device, it's kind of a horrible shaped black box and it just doesn't look as neat, whereas this, we can put this next to the existing consumer unit and it will just blend in. It will just look like another consumer unit really. So it's quite nice, and we can just put a conduit bush through the side and just run the cable straight through from one consumer unit to the other. So I'm quite excited to use this today, and be interesting to see how we get on with it. So the charger is just going to go on the wall here with the kind of cable holstered there. The actual Ohme box will go here, and then we'll probably put the junction box down here somewhere. We're not coming off the meter box, but the consumer unit is literally just through the wall there, so hopefully we can clip the cable along here, drill through the wall at an angle, and then we can literally come through somewhere here, put our new consumer unit box here, and then we can just add a new circuit in here which will feed across to the new consumer unit box, which has the 10 volt detection device in, and then go straight through from there to the EV charger. So I'm going to have to reconfigure this slightly because obviously we've only got RCD protected circuits here. We need to actually free up a spare way on the non-RCD side, so we're going to have to shift everything across slightly, but that shouldn't be too difficult. So let's get cracking. So as you can see here, we've got a spare way here and a spare way here, which is great. So what we can do is basically move this one across to here, shift everything that way slightly, and we just have to do a little bit of alterations, obviously fit a new bit of bus bar under here. But I've got some bus bar on the van, so that should be okay. And then obviously you're going to have to relabel the consumer unit, which is the fun part. Then from the side of this consumer unit, we can hopefully put a little bush and coupler into the new consumer unit on this side, and then I'm hoping I can drill directly through the wall at an angle and just come out exactly in the right place that we want to with the cable. So it's going to be a little bit of fun drilling, but I think it should be doable. Don't you just love it when a plan comes together? So that hole went straight through and came out here, which is perfect. So we can then run the cable down here along into our junction box, and then from the junction box into the Ohme. So that was the bit I was most worried about, to be honest. So I'm really glad that went in. That went in well. That is a massive relief. I mean, you guys have probably seen me use these before on other videos, but these long drill bits are an absolute game changer because you can get such a good view of what the angle is that you can drill really accurately in a just at the right angle to come out exactly where you want. So I highly recommend these, even if you don't need a full length. It's just the length helps you get the angle right, which is really important. So now basically I can mount this up on the wall, put a grommet in the back of there, or maybe even a bush. sort out the MCB in here, cable through into here, into the feed, and then out of there, through the wall, into the charger. So I've got this 4mm 3-core NYYJ cable, which is going to be used to go out to the charger. It's obviously great for this kind of situation because it doesn't need to be armoured, it's not a long run, there's no potential heavy damage or anything, but it's black, it's resistant to UV and all that stuff, so it's perfect for this kind of installation. So I'm just going to send that through. I'll probably send it through from the other side. Right, so we've got the new consumer unit mounted up, and that's just got a lock ring with a male bush, and I've put another lock ring in the middle just to space it out slightly because the lid of this overlaps by a few mil, so we don't want the lids to clash with each other. Got the cable in there, which is running down through here, so that is going to then clip down here and along into a junction box that we're going to put on here somewhere, and then that is where the Ohme cable will connect into. Interesting that they use black, white and green. Obviously they give you a label to say what's what. Black is live, green is earth, white is neutral, but I'm not quite sure why they use those colours. Seems a little bit odd to me. Let me know in the comments if you know why. Right, so everything's mounted up. It's gone on quite nicely. I've just got to clip this cable, get that to the right length, and then do the terminations on here. This is the holster, so it basically just allows you to hook the cable up neatly, and then this is a holder for the Type 2 cable, so you can just click that in and it sort of stows it out of the way, which is quite nice. It looks neater than I expected actually. I was kind of a bit worried about how it would look with the cable and stuff, but it looks fairly decent. So now I'm just going to clip this up, terminate those cables in there, put the lid on, and then start connecting up everything on this side. So now I've got to just terminate this into here. So we've got CPC, line and neutral. So we'll just terminate that into there. This goes into the earth bar, and you have to be careful with these not to, if you're using armoured cable, not to connect the armouring to the metal casing, otherwise it won't isolate the CPC if there's a pen fault, because the CPC will continue through the armouring. So that's why it's good to actually use NYYJ if you can, or just use steel or armoured but put it in a compression gland so that you don't continue the earthing of the main system through to the charger, because it needs to isolate all three. It needs to isolate the CPC, the line and the neutral in the event of a pen fault. So that means that the only CPC going to the charger has to be going through this contactor. Right, so this is all connected in now, so that comes in at the bottom, loops round and in to the outgoing side of the chint contactor. That is the earth that comes from the earth bar, so this will feed an earth from this one to here, and then phase or line and neutral will go from the circuit breaker and the neutral bar here. So I've just got to feed a cable through here. I'm going to turn everything off here so that that's safely isolated before I start working in that main board. juggle everything round, put a new circuit in here, and it'll be good to go. Right, so this is all done now, so I've shifted everything across slightly, taking the 32 amp breaker from there and just put it into here. So that's all good. A little piece of bus bar in there just to connect up, or bus bar. Then I've shifted the CPCs across, put this in number 1 slot, this one in number 1 slot here, and then obviously the line conductor coming in. So they come in, the line and neutral come in the bottom here, and then the CPC comes in to here. So all good, quite a nice neat little board really, and it's just great because it's the same size as the consumer unit, so it just looks really nice and neat, and I think it's a nice result. So this is all livened up now, and interesting, so when you turn the main switch on, it runs through a few little flashing lights and stuff. There's a little LED hole there, you can see the lights flashing through there, and then it clicks in the contactor. But the great thing about this contactor is it's very, very quiet, so you really can't hear it at all. Obviously it's a normally closed contactor, so if there's a fault then it will open up and break contact to the line, neutral and CPC to the charger. And I just love it. I think it looks really good. So through here we have a green light now, and we've got our charger all illuminated and ready to go. So we've just got to pair it up with the app and then run some tests on it, and we'll be all good. So just doing the testing on the charger now. So you can see it's got a red light, that means it's basically active, and my polarity is showing as okay. That's all good, and I've done an earth loop impedance test, and I've got 0.37 ohms for earth loop impedance on there, which is brilliant. So all good. See if we can do an RCD test on it, see what happens with that. Sometimes they work, sometimes they don't. So half times. Okay, so that's tripped the RCD, 23.5 milliseconds. And then that's not reset itself yet. So it just resets itself automatically basically, which is good. So we'll do this again. Turn it off, turn it back on again. Okay, and that sounds like it's triggered the pen detection somehow. Turn it off, turn it back on again. And that is dead. So it will be interesting to see what's happening with this. I've got a red light on there now. Okay. So let's turn this one off and back on. Okay, that's kicked in now, and our charger's kicked in again, and that's so the 5 times. For some reason it's tripping out in here as well. Which is not necessarily a bad thing, but there we go. And that's livened up and all good now. So that is it. So charger is in, everything's cleaned up and ready to go, all tested out. So all we've got to do now is basically have a little go at plugging the vehicle in, get it paired up to the app and do all the grant paperwork. And that is all. So all in all, what would I say about the Ohme charger? Not bad actually. I think it seems to be reasonable quality. Only time will tell. Doesn't look the most beautiful, but it doesn't look hideous either. And it's simple to install because there's no moving parts in here. So you just literally connect the cable up. The fact that it's got RCD protection built in is good. The only thing is it does need a separate pen fault detection device or an earth electrode installing, so that creates a little bit more of a headache for the installation compared to, say, a Zappi, for example. But I like the fact that it does alter your charging times based on the cheapest rates for electricity. I think that's really, really clever. So yeah, maybe looking forward to installing a few more of these in the future. As always, if you've enjoyed my videos, don't forget to hit the thumbs up, subscribe. Look in the description below, you'll see much more videos for EV charging if that interests you. And as always, thanks for watching and have a great day.